Now what we want to look at is figuring out what the charges are on those monatomic ions and then figure out how we get the formulas from the compounds that result from the combination of a cation and an anion. So the first thing we want to worry about is the types of ions. First off, we want to look at what we have. We have cations and we have anions, and cations are positive, anions are negative. Okay. And what we're going to look at for the size of those is that we have monatomic, meaning we have one atom, and we have polyatomic, which means many atoms. Okay. Now, when we deal with these monatomic ions, we have to worry about two different things. We have to look at the fact that we have what are known as our main group. So the first two columns and the last six columns, those are our main group elements. And then we have to worry about the transition elements. So all of those elements in the center of the periodic table, because their behavior is a little bit different. So right now we're just going to be worrying about the monatomic ions, not the and only those main group ions. We'll later look at transition elements and the polyatomic ions. So when we look at our main group elements, what we find is that all of our atoms in this first column will form ions with a +1 charge. In the second column, they'll form a +2 charge. Over here in this 13th column, they form +3. We notice that we don't have a charge here in this column here headed by carbon, and that's because these elements kind of behave differently depending on what they're partnered with. We can't have carbon that has a -4 charge acting more like a nonmetal and forming an anion. We don't see that too frequently, so we're not going to worry too much about these guys. When we get down to tin and lead, we start to see some more transition metal-like behavior that can explain their charges. However, we do go over here to our fluorines. We see we get a -1 charge. Notice there's no charge here on the noble gas column because these elements are perfectly happy the way they are. They don't want to gain or lose electrons, and so they are not going to do that. And as a result, they don't form ions. When I look at fluorine, I see that it's one electron away from neon, so it needs to gain one electron to look like neon, so it's going to have a -1 charge. The same thing is true for chlorine and bromine and iodine. For oxygen, we see it's got a -2 charge, and that's true for sulfur and selenium as well, because we need to gain 2 electrons to look like neon. Nitrogen and phosphorus each need to gain 3 electrons to look like neon. So notice it's about gaining electrons here, taking on a negative charge, or on the other side of the periodic table, looking at lithium and sodium, for example, we say, well, they're going to lose 1 electron to look like the nearest noble gas, and as a result, they're going to be left with a +1 charge. But again, the columns help us easily predict the charge on those ions. When we get into electronic structure, we'll talk more about electron configurations, and we'll have a better understanding of why it is they're going to lose electrons and or gain electrons in the case of our nonmetals, which become anions. So metals are cations and they lose electrons. Nonmetals are anions and they gain electrons. So the easiest way to see how these compounds are formed and what those subscripts are going to be is actually to look through some examples. And so what we're going to look at is if we have lithium and chlorine. So what we want to do is look over here on the periodic table, and we see lithium is way over here on the left. It is a metal. It's on the left side of the periodic table. Metals tend to form cations. Lithium has 3 electrons. Helium only has 2 electrons. So lithium either has to lose 1 electron or gain 7 electrons to look like a noble gas. And so lithium goes, you know what? It's easier. I'm just going to lose 1 electron. So when lithium, which had 3 electrons and 3 protons, loses an electron. Now it has 3 protons and 2 electrons, so it's going to have a +1 charge. Now I can look at chlorine, and I look where chlorine is in the periodic table, and notice that I have Cl here. If I look at the number of electrons in chlorine, what I see is that I have 17 electrons, and so I need to gain one additional electron in order for it to have the same number of electrons as the nearest noble gas, so argon. So when I look at the neutral atom, what I see is 17 protons, 17 electrons. But as I gain that electron, I go to 18 electrons. So now I have one more negative charge than I have positive charges. So chlorine is going to have a -1 charge. Now notice that when we have these ions, if it's a plus or -1, we don't actually include the 1. We just write plus or minus. Now I've got to figure out what the formula is. Now I can look at this and say, well, lithium is losing 1 electron, chlorine is gaining 1 electron, so I must have lithium chloride. Another way we can do this to figure out what the subscripts are is what we call the crisscross down method, where I take the value here, the absolute value of my charge becomes the subscript, so I would have lithium 1, chlorine 1. And now I don't need to write those ones in there because it's an understood one if it's not there, so I can simply write this as lithium chloride. Now I have 1 lithium, which has a 1 plus charge. I have 1 chlorine, which has a 1 minus charge, and when I add those up, I get 0. So I have my electrically neutral compound. 1 electron lost by lithium, 1 electron gained by chlorine. Now let's look at an example where we're not dealing with plus and -1 charges for both ions. Now we want to look at magnesium. So I look at magnesium Mg and Br, so bromine. When I look at my periodic table, I look at magnesium here. It has 12 electrons. Magnesium wants to lose 2 electrons, so it'll have 10 electrons just like neon does. When it loses 2 electrons, it's going to have a 2 plus charge. And we also see that it's here in that second column, so all of those elements are going to have a 2 plus charge when they form an ion. Bromine is in the same column as chlorine was that we looked at in the previous example, and so just like chlorine, bromine is going to have a -1 charge. We don't need to draw the 1 because it's understood when we just have the minus sign there. Now we can't have MgBr because now we have magnesium is giving up 2 electrons, but each bromine can only take 1 electron. And in order for that to work out, if magnesium is giving up 2 electrons, then the bromine or some combination of bromine ions bromine atoms have to accept those 2 electrons. But each bromine can only accept 1, therefore we need 2 bromine ions. So now we can look at our crisscross down, okay, and what we get is we have magnesium Br2. So now when I look at the charges, I see I have 1 magnesium with a 2 plus charge, plus 2 times a 1 minus charge on bromine, and the sum of those values is still equal to 0, which is exactly what I need for a neutral ionic compound. I must be electrically neutral.